Alright guys, welcome to Algebra 2. This is 313 and we're going to be talking about rewriting problems in order to solve them a little bit easier today. So we talked about last time, we brought up the idea of a U substitution where we can replace things with U just to make it look a lot nicer for us to solve. And that's kind of the same line as we're going to be approaching stuff today. So how can we change this to make it look prettier so that we can solve it a bit easier? So number 37, we have x squared plus 2.5x minus 1.5, and say, hey, well, we have those decimals. Decimals are really nasty to try and factor with, so we're just going to use the quadratic formula on it, and that is a totally viable option which you can use. But factoring is always a little bit faster if we can do it. So can we change that problem ever so slightly to make it not have those decimals? So go ahead, pause, try and figure out what you could do to that problem to get rid of those decimals, and then once you've done that, then try and factor it the way we've done in the past. Okay, so how we could approach this, you might say, well, if I could multiply everything by a 10, because then that moves the decimal over one spot, and then I get 10x squared plus 25x minus 15, and that will work, and you can factor it, and it factors just fine, right? But it makes your numbers a bit larger than they need to be. So what I'd recommend saying is, well, that's 2.5, which is 2.5, and then 1.5, 1.5. So really all I gotta do is double stuff, right? Multiply it all by 2, and then I'll have those decimals gone anyway. And that keeps my numbers a little bit smaller, a little bit more manageable. So if we do that, we're gonna end up getting 2x squared plus 5x minus 3. Okay, so now if you do our little box method here, I'll draw it out. I get 2x squared, and this becomes negative 6x squared. So then I would need to pull out, multiply to be this, add to be that. It's going to be negative positive 6, negative 1. So then I can pull out 2x here, pull out a negative 1 here, I can pull out an x here, I can pull out a 6 here. So I end up getting 2x minus 1 and x plus 6 is equal to 0. So then I can use my zero product property to actually solve it out and get 2x minus 1 equals 0, which is 2x equals 1, x equals 1/2. And over here, I would get x equals negative 6 as my two solutions to it, right? So I could factor it a little bit faster. Now that is a bit faster than using the quadratic formula on it. Again, and Alg2 was just trying to rewrite it in a format that's a little bit more user-friendly. That's effectively what we're trying to do. So on 38, what I want you to do is on these four, some of them are systems and some of them are just equations. Figure out how could you rewrite that to make it a little bit prettier, a little bit more easy to work with. And then once you've done that, then try and solve it out. If you're having a hard time with the solving it out part, that's fine. At very, very least, try and rewrite it in a much prettier form. Try and get it at least to that point there. So go ahead and pause, try that for those 6, and then come back here. Okay, so if we take a look at this first one, right? I have 100x squared plus 100x is equal to 2,000, so it's got big old numbers, right? If I were to divide everything by 100, right, I'd get x squared plus x equals 20. That's pretty easy for me to work with. So let's go ahead and do that, right? I have x squared plus x equals 20. So I'm going to have x squared plus x minus 20 equals 0 because I need to get it all equal to 0 before I try and factor. So I need to multiply and be negative 20, add and be a positive 1. So that would factor into x plus 5 and x minus 4. So then if I solve it out, I get negative 5 and positive 4 as my solutions. So again, drastically easier once I've changed those from those big old numbers down to stuff that's a lot more manageable for me. Okay, on B, we have a system here. 15x plus 10y equals negative 20. Then I have 7x minus 2y equals 24. So here, the top one, I just see, hey, all of these are multiples of 5. So I could divide everything by 5 and get 3x plus 2y equals negative 4. So let's try that. So in this system, let's do that. I have, after I divide by 5, I'm going to have 3x plus 2y equals negative 4. And then my other one was 7x minus 2y equals 24. Now on this system, I'm going to do addition here because I see that these y's are going to cancel just as is. So I definitely want to do addition over substitution here. So when I add everything down, I get 10x, no more y's, and then 20. So divide by 10, x equals 2. Great. And then to find my y, I can plug this 2 into any one of my original equations. I'm going to plug in the top one because it has a little bit smaller of numbers. So that's going to be 3 times 2 plus 2y equals negative 4. That's 6 plus 2y equals negative 4. That's 2y equals negative 10. Y equals negative 5. Done. Right? So again, not too bad on that one. On C, so here we have some fractions, right? We have a third, we have a half, and we have a third. So we can't just multiply everything by a third because that's by 3 because that won't get rid of this half. And I can't just multiply by 2 because that won't get rid of the thirds. So you can do this in two different ways. You can first multiply by 3 and then multiply by 2. Or you say, well, to do those both at the same time, I'm effectively multiplying by 6, which is the common denominator of 2 and 3. So I multiply everything by a 6. That'll get rid of all of my fractions, and then I should have a much easier time trying to solve that one out. So let's go ahead and do that. So I'm going to keep it bigger so I can read it because it's a little bit small for me. I have 1/3 x squared plus, I'm just going to call it 1/2 x. Minus 1/3 equals 0. Okay. Okay, so here we go. If I multiply everything here by a 6, right? This time becomes really easy because 0 times 6 is going to stay 0. So here I get, this becomes 2x squared. If I do this 6 times the 1/3, 6 times the 1/2 will give me a plus 3x. 6 times the 1/3 will give me a minus 2, and again, still equal to 0. Okay. All right, so then you might have done this part a little bit differently, but how I factor when I have those numbers out front there is I multiply to be this times this, which is negative 4, add to be this, which is 3. So that's going to need to be a positive 4 and a negative 1 in order to get that to happen. So then when I draw out my box for it, I'm going to have my 2x squared here, my negative 2 here, and then 4, negative 1, tack on the x's. So then when I pull out my greatest common factors, I'm going to get 2x out of this. I can pull out a negative 1 here. I can pull out just an x over here, and I can pull out a 2 over here. So that factors into being 2x minus 1 and x plus 2 when it factors. So a whole lot easier once we've kind of gotten into that much prettier form than working with all those ugly fractions, right? Okay, so let's hop back over here. And let's take a look at D. So on D, our fractions are x squared and x. So that's kind of nasty there. So what we want to do is, again, multiply by the common denominator, which is going to be x squared. So when we do that, we're going to get 4 plus 12x, because one of those x's would cancel, and then plus 9x squared equals 0. So now, again, it's kind of written a little bit different than we're used to, but we can just reorder that as 9x squared plus 12x plus 4 equals 0. So I'll do a little x. I need to multiply and be 36. And then I need to add and be 12. So things that are going to do that for me are going to be 6 and 6. That's the easy one. I just didn't see it. And then go out and draw out my box for this. And I'm going to have 9x squared and 4, and then I got 6x and 6x. So I can pull out a 3x here. I can pull out a 3x here. I can pull out a 2 and a 2. And we get 3x plus 2 squared. I just realized that I forgot to actually solve the last one. I just factored it. It's equal to 0. So that one would be x is 1/2 and a -2. And then over here, this is equal to 0. So I'm going to get 3x plus 2 equals 0. That's 3x equals -2, or x equals -2/3. And you'll get that twice, but it's the exact same answer both times. So -2/3. All right. Then if we go on to E, so E we have x and then x minus 1 on the bottom, so I'm going to have to multiply by x and x minus 1. So this one, which I'm going to write out a little bit more fully just so we can see everything that's going on here. X minus 3 over x plus 2 over x minus 1 equals 5 minus x over x. Okay. So again, if I want to get rid of stuff here, I need to multiply everything by x times x minus 1 on both sides. So this times this, the x's cancel. I am left with x minus 1 times x minus 3. Here, the x minus 1's cancel, so that's just going to be 2x. Over here, the x's cancel, so I get 5 minus x times x minus 1. Okay, so kind of ugly, but we can multiply things out and start to combine some like terms. So if I multiply this out, x times x is x squared. Then I get a minus x and a minus 3x. That's minus 4x's total. And then that's going to be a plus 3. And I have plus 2x still hanging out. On this side, if I multiply this, I'm going to get 5x minus 5 minus x squared, and then plus x. So again, that one's a bit wonky because it's not in the typical order, but not a huge deal. Combine some like terms here, I get x squared minus 2x plus 3 equals, over here I'm going to get a negative x squared plus 6x minus 5. So then I'll add that x squared over this side, and I get 2x squared. Subtract this over, and I get minus 8x. And then add that over, and I get plus 8 equals 0. So, phew, kind of ugly, but hey, I can actually make this a little bit easier, because now I see, hey, 2, 8, and 8, let's divide everything by a 2. Now I get x squared minus 4x plus 4 equals 0. So now I can factor with that shortcut method. Multiply to be 4, add to be negative 4. It's going to be -2 and -2. So that's x minus 2, x minus 2. So then my answer is x is 2, and I get that twice. Now the only thing that we have to watch for, because we had x's in our denominators here, is x can't be 0 because it would make this d divided by 0, and x can't be 1 because it would make this d divided by 0, but luckily that wasn't our answer, so this one works. That one is probably one of the hardest ones we're going to be encountering for quite a while, so if you did well on that one, you should be feeling pretty darn good. Okay, then last part here on f. Okay, so we have square root x squared minus 15x all over 2y. Okay, and then we have 3 times the square, this big radical, x squared minus 15x minus 3y. Okay, so I'm going to want to deal with this whole big old x thing, right? So I could square it and then try and get rid of that, but I'm going to do a u substitution here, like we did last time. And I'm going to let u be that big ugly radical, which was the square root of x squared minus 15x. Okay, so then I have u over, is it 2y? Yes. Equals 5. And then I have 3u minus 3y equals 27. So now this is a much more reasonable thing for me to try and work with, right? I can pretty easily get u by itself by multiplying both sides here by 2i, and I get u equals 5 times 2y, right? Also known as u equals 10y. So now I can plug this 10y into the u here. And I'm going to get 3 times 10y minus 3y equals 27. So that's 30y minus 3y equals 27. Well, that's going to be 27y equals 27. Divide by 27, and I get that y is 1. Okay. Big part done. Now I can solve for what u is, right? If I plug in y here, I get u is 10 times 1, or just 10. So u equals 10. Now, I don't care about u, I care about x, though. So I'm going to now plug this in here to actually solve for what x is. So I have 10 equals big square root x squared minus 15x. So I'm going to square both sides to get rid of that big old radical. And that gives me 100 equals x squared minus 15x. Well, I want to subtract that 100 over, and I get 0 equals x squared minus 15x minus 100. So now I can try and factor this. So I need to multiply to be 100, multiply to be negative 100, add to be negative 15. That's going to be 25. So I get x minus 20, x plus 5. So then that's equal to 0, so do my 0 product property on it, and I get that x equals 20 and x equals a negative 5 as my solutions there. So then we're going to check, say, hey, do all of these things work? Because I got multiple x's, and I can plug them in and check and say, hey, do those ones actually work for me? All right, so with that, some of these today were quite challenging, right? 38 has some nasty problems, but the whole point is to get you to say, hey, here's things that I can do to it to make it look easier and a lot prettier to work with, right? That's the main thing that I wanted you to get out of this. If you weren't able to do all of those in entirety, that's totally fine, right? I would be very impressed if you got A through F with no help at all, right? Those are quite challenging problems. But what I wanted you to do is, hey, how could I rewrite this to be easier for me to work with? Because that's our kind of main goal for this particular section. Okay, so that is it for day one here of 313. So we're doing 45 through 50, and I'll talk to you guys next time.